Thank you everyone for joining us. Welcome to 24 Hours of PASS, SQL Server 2014 edition. We're really excited you could join us today. Jost, I can't pronounce his last name, I'm not going to try and butcher it, and Sunil Agarwal are hosting an Ask Me Anything session on SQL Server 2014 in-memory OLTP. So please, the speakers have some questions that they've prepared. You can go ahead and start typing away your questions right now, and we'll start bubbling them in. We have 24 consecutive live webcasts. The recording of the sessions will be available next week at 24hoursofpass.com. My name is Aaron Nelson. I work for Slalom Consulting, and if we will be doing this session for 40 to 45 minutes or until we run out of questions today. Sunil, if you could advance the slide. Thank you. If you're having any issues, please just use the raise your hand icon on the right side of your screen and someone will assist you. To maximize your screen, use the Zoom button located on the top of the presentation window. Feel free to enter your question in the Q&A field at any time. Like I said, we're going to be taking questions throughout the session, so go ahead and get started, and we'll start queuing them up. The question pane is located on the right side of your screen, and I'll be reading the questions out to the moderators so that they can go through them and trying to take the questions that are being asked the most frequently first. Please remember that there's an evaluation page that will jump up at the end of your session, and your feedback is extremely important. Please take time to complete that. Definitely need your feedback. Definitely helps. Sunil, if you could go advance to the next slide. All right, and before we get started, we wanted to say a big thank you to Microsoft. They're our event partner. Microsoft is also one of the global sponsors of the PASS organization and PASS Summit. This session, this whole day would not be possible without their support and dedication, and they are the reason that this event is available free of charge. Speaking of the PASS Summit, so if you could advance the slide. I want to bring your attention to the PASS Summit. It will be taking place in Seattle, Washington at November 4th through the 7th. It will feature over 200 sessions with world-class SQL Server experts. Planned and presented by the SQL Server community, PASS Summit is single-handedly the largest gathering of SQL Server and BI professionals in the world. Over 5,000 attendees from all over the world, not just Microsoft employees obviously are going to be close by coming from Redmond, but also MVPs like myself as well as other experts from around the world. Most importantly, PASS delivers on providing with the answers to your SQL Server issues along with the knowledge, strategies, and skills you need to stay ahead of the curve. Contact your local chapter for a discount code, and you can save $150 on your registration. It's best to register before Friday, June 27th, because there's even more savings to be had if you do by then. All right, and to find out more about the PASS Summit, go to passsummit.com. And then Sunil, if you'll take us to the last slide. And that's it for me talking. I'm going to let, well, as far as this introduction, I'm going to let Joss and Sunil introduce themselves, and I'm going to go ahead and start organizing the questions and getting them ready for them to answer. Go ahead.
Okay, thanks, Aaron. Maybe I can go ahead first. So my name is Jos de Bruin. I'm a program manager in SQL Server Database Systems team. I've been with the team now almost 4 years, and my main focus has been the in-memory OLTP feature. We call this a hackathon project. We brought the feature to SQL 2014, and we're still working on improving it for the next release. Sunil.
Yeah, thanks Yos, and thanks Aaron. My name's Sunil Agarwal. Like Yos, I've been a program manager with SQL Server team. Stayed a little longer than Yos. I says 8 years, but I've been here for almost 12. I've been working with Yos on in-memory OLTP. My focus has been mostly on the storage side, and Yos' focus has been on the query execution optimizer side. So both of us should be able to cover the questions that you have, and it is really exciting to be here to answer the questions you have. So with that, I'll go to the main slide. So one thing that me and Yos have done is put together a list of questions that we have heard from customers during our engagements through customers on one-on-one basis or sometimes as part of the conferences. But I think the most important thing is that we hear your questions and answer those questions. And Aaron actually is figuring out those questions. And Aaron, I think as you have questions, we can take them. Otherwise, we can go to the sequence that we have here.
Yep, we've got 5 questions in the queue already. If you want to get started with one of them, we could start with one. Yeah. The first one, and it's a great question, are in-memory objects automatically loaded into memory during server startup or after their initial use?
At the startup.
At the startup. Perfect.
Yes, I want to add to that actually. So there is a little bit of nuance. So your memory optimized tables, they are loaded in memory during server startup. So it's not only the objects are created, but also the data is loaded during database recovery, during database startup, so that it's ready to access right away. But for natively compiled stored procedures, they are compiled actually on first use after a server startup.
Gotcha. To expand on that a little, let me just throw this question in there. Are we saying that that people should expect to see a lot of read activity from their disk drives after they reboot a SQL Server with memory optimized tables?
So just let me respond to that. Answer is correct. So one of the things we have optimized in-memory OLTP engine for is we want to be able to load the data at the speed of I/O. So it can be parallelized. Suppose you're running on a 16-core box during recovery or the restart. All 16 threads will be working in coordination, loading the data in memory, and for most scenarios it is loading the data at the speed of I/O. But you're right, it will see a lot of I/O activity for that short duration.
Okay, great. We've got several more coming in all at once. Let's see, let me ask this one because I actually haven't heard too much talked about this recently. What is the effect of using in-memory tables in log shipping, especially how the standby mode works in secondary database or in always-on readable copies?
Right. So just let me take this.
Yeah. It's your field, so.
Okay. And feel free to jump in. So the log ship. So let me just answer the question in a more broader sense. So there are two. Essentially, what happens is, so people have log shipping because they want to be able to query the data on the log ship node, and if you extend that further with the SQL 2012 onwards technology with always on, where again we are applying the transaction log on the secondary replicas. So in both scenarios, when you have, so let me first touch upon always on, and I'm going to link back to the log shipping. So in always on, the transaction log records are coming to the secondary node, and when they are applied, the data is loaded in memory. So for example, you have a in-memory OLTP table, and you are inserting multiple rows on the primary node. Those insert log records are being shipped to the secondary replica, and redo thread, or the thread that is applying those log records, will bring those rows into memory. So when you have a failure, like suppose you want to switch from the primary node to the secondary node, the data is already in memory, so you should be able to fail over very quickly, number one. and even if you don't do failover, you want to run reporting workloads on the secondary, they are available for the reporting workload. So that is the case with always on with in-memory OLTP tables, right? Log shipping is exactly very similar, because in log shipping you are applying the logs instead of automatically, you are applying through a script. And again, as redo thread is applying those log records, the data will be in memory for in-memory OLTP tables to the point where the log records have been applied. So both cases work well. So I hope that answered the question. Joost, please feel free to add something.
Yeah, I believe, actually correct me if I'm wrong, Sunil, but I think log shipping with standby is not yet supported, is it?
I need to check on this one, but I thought it was, but let me check on that.
Yeah, okay.
All right. I've got another question queued up for you guys, and it sounds like a great question. When I have X amount of gigabytes of memory allocated, so I've got my SQL server, and I'm talking about my total amount of RAM that I've got dedicated for the whole server, and let's say I've got my in-memory tables, and they are gradually growing. They're getting larger. Does that mean that they would be slowly taking away RAM available to the rest of my SQL server, the more traditional SQL server functionality, as those in-memory tables grow in size?
Right. So just let me take this. Yeah. This is again the memory side. So great question. So one thing that you know is the in-memory OLTP tables must reside in memory. There is no paging of in-memory tables. So what it means is, if you have created a table as in-memory table and data is growing in that, it is going to consume the memory from SQL Server process and is not going to give back. It's not going to give back. Of course, when you delete the rows in the table, when you delete the rows, those will get garbage collected automatically, so you get some memory back, but it grows, right? So the basic problem is, how do I manage the memory given to the in-memory OLTP tables and my other tables and other, in fact, applications running on the same instance, for example, in different databases? So what we have provided in 2014 is a way to control how much memory can be given to in-memory OLTP tables at a database level. So you can create a setting in the resource pool and map the resource pool to the database. You can say that database DB1, for example, can take up to 20% of my physical memory from this process. So that means your in-memory OLTP tables cannot take more than 20%, so you have the rest of the 80% available. I'm saying in a very generic sense, available for every other table or every other workload. And of course, when you exceed the memory that you have allocated or kept aside for your in-memory OLTP tables, of course, as you insert more rows, those insert transactions will fail because there is no more memory left to accommodate that. So what you can do at that time is, if you have more memory available, you can change the resource pool settings, say from 20% to 30%, and now you have 10% more memory available to load the data. So that's how you manage it.
Right. Great. And Sunil, I actually just tried to assign you a question. I don't know if that worked. I'm going to go ahead and skip to the next one in the meantime, because I see this question from multiple people right now, and that is, what are the use cases when to use a durable versus a non-durable table?
Okay. So as the name describes, the durable table are the ones that are fully persisted. They survive the restart, and if you want to access them on a with the data, you want to access anywhere, say on the secondary, they're available. So any time in your application you have tables that you must have, you cannot lose the data, that by definition is a durable table. Now for non-durable tables, we are saying the transient data that you don't care about the durability. One common example is staging table. When you are loading data into your database system, you're loading from external files, and I mean, I've seen many customers asking, we talk about minimal logging, right? People say, hey, can I just remove logging completely, because I know if system has to crash, which is of course rare, I can reconstruct my data because I have data sitting in the data file. So in those kind of scenarios where you have data sitting like in external files, you can use non-durable table for staging, do some cleanup, and finally move the data into a persisted table, which could be in-memory table, or it could even be a disk-based table. That is one. Other scenarios that we have seen non-durable table, in fact, has been deployed in production by many customers, is like a session state kind of an application where, for example, I'm logging into a website and I have my session active. So in many cases, customers said, okay, I don't care if the system goes down. I mean, this is rare. If it goes down, then I lose my sessions. People have to enter their shopping cart again. I mean, that kind of scenario. So they can just use non-durable tables instead of durable tables to get around the problem, right? Of like, I mean, to reduce the expense on the storage and the logging. So that's another way to do it. Of course, if system crashes, all sessions are gone. There is a poor experience on the customer side, but that's a compromise you have to make as an application designer. Yunus, anything else you want to add?
Yeah, well, just one point I want to emphasize is that you will want to use durable tables always as the default.
Correct.
Your defaults are always going to be durable tables, and only when you have a very specific scenario that you will want to make a choice for a non-durable table, because it can and it has already caught people off guard that the data is gone after a restart. Right? You don't always think about it. You may think, oh, I need this only temporarily, but then you accidentally restart the server and the data is gone, right? So that can lead to issues. So you need to make a very conscious choice. Say, hey, my scenario really needs a non-durable table, and it is indeed the two key scenarios that Sunil mentioned: the ETL scenario with the transient data and the session state, where it's also essentially transient because you can just recreate the session state on the fly. It's only you make this really conscious choice. Otherwise, stick with durable.
Right. Let me add one more point, Aaron. I said that also. Like, since non-durable tables are not logged, if you are running in a configuration with always on, the data on the non-durable table will not be visible on the secondary. So that is another thing to be aware of.
Okay, that's perfect. I think you may have just answered one of the other questions that we had in the queue. Let me to clarify on the ETL point, if someone's doing ETL and they're using it as a load table or a staging table, and it's a process where, hey, if the server reboots, you got to restart the load process anyways, or you might as well go ahead and restart it anyways, then it's a good idea to use a non-durable table. But in other scenarios, you're going to want to default to durable. Does that sound right?
Yeah. Yep.
All right. Cool. Excellent. One thing, do you guys have a code example for that splitting the memory assigned to in-memory tables versus the rest of SQL Server? I think that might help answer some of the questions.
Okay.
We're getting
okay.
lots in the queue now.
Right. So first thing, I can show something very quickly. So one thing that I want to say is, right, from a user perspective, right, you just declare in-memory OLTP table, and you insert rows, memory gets allocated in the background, right? So that's the behavior. Now, I think what the question is alluding to is, how do I map a database which can have one or more in-memory OLTP tables to a resource pool? And on that, I just want to show a very quick example, if you allow me. I go to this guy, and I just need to do a quick search on my memory thing, and memory simple demo, and sorry, I need to okay, there you go. So here, I hope you can see the screen. So basically what I have done is I said create a resource pool, and I said this resource pool has 40% of the memory available to the process. And then what I do is I run this stored procedure, which is XTP bind database resource pool, and I'm saying my in-memory OLTP database is bound to this pool. And once it has been bound, you need to take database offline, online to make this mapping applicable. So you need to take database offline, online. Now the mapping is available. And now anytime you insert rows into memory optimized table, SQL Server will make sure that they do not exceed the memory available through the resource pool. So that's how it is done. I hope that answered the question, Aaron. Was that the intent, or there is something more than that?
Yeah, I think it did. I was multitasking with, we're getting a flood of questions in here.
Sure. Carry on.
I think you did.
Okay. Go back to the slide.
Yeah, sure. So let's go with this question. Would you recommend using non-durable tables in ETL, BI, DW situations?
Answer is yes.
Yes. Okay, great. That was quick and easy. Let's see. Let me go ahead and ask this one to you. It is, how does in-memory work in the case of clustering and after a failover?
Okay. So it looks like all the questions are on the storage side, so you're sorry. let me take that. So,
I've got several app questions here in just a minute. I'm just trying to.
Yeah, you should mix those. So one of the value propositions we have with SQL 14 in memory OLTP is that it is integrated into the SQL Server, right? What it means is, from a DBA or from a user perspective, everything just works like the way it works before, like always on, the example I gave before. Now the failover clustering, which is also a part of always on. Failover clustering is like you have two nodes on the shared disk environment. So clearly when the failover happens, the data has to be loaded from the shared disk onto the new node, the failover node where the SQL Server is getting restarted. So that scenario is exactly similar to a restart. So it just works. So failover clustering is fully supported with databases with in-memory OLTP tables.
All right. Let's see. There was one. Would ASP session state be a good use for non-durable tables?
Absolutely. In fact, let me make one point. I think Jos and I both talked about that point. We have a customer. I mean, our one of the first customers who went in production with session state with non-durable table is Bwin. I mean, they have been very vocal about the benefits they got. They got currently in production environment 20x gain. And so they have been using it. And then there are customers who are using session state, and they wanted a durable table because for them, like Jos was pointing out, you have to really look at your example or customer things. So they can, I mean, from an application perspective, right, it's just a metadata thing, whether this table is durable or not durable. So you can use session state in both scenarios. But yeah, session state, ASP.NET is a very common non-durable scenario. And in fact, I think this is not yet published. We are gonna put on the Codeplex a implementation of ASP.NET with non-durable table implementation using Hackathon. So it will be available for everybody to try it.
Oh, awesome! Sounds great.
In fact, it was just published. Sunil, I'm just sending you the link. Maybe you can show it on the screen.
Okay.
It was just published. We have not yet written the blog post or done a PR around it, but it is now available on NuGet.
Yeah, so I'm just I've not seen your mail yet, but I'm going to show that.
It is in link. I think everyone can see my link message.
Okay, that's cool.
Yeah.
Yep. All right. So let's see. The next one was, could Hackathon be used as an in-memory cache for middle tier as an alternative to App Fabric cache, for example, or Redis, R-E-D-I-S?
Okay. Jos, why don't you carry on?
Yeah, I can take this. Well, the way we implemented Hackathon in SQL Server 2014, it is part of the core database system. So it was designed to live in the data tier. So it is not really designed as a mid-tier caching solution. Now we are thinking about maybe in the future we will want to do something like that because the engine Hackathon engine, the in-memory OLTP engine, is relatively self-contained, so potentially you could embed it also in some other applications. But we don't have that capability just yet. Now, I do want to say that using Hackathon as a relational cache, I mean, that is in principle a supported scenario. It would not be embedded in your application, but still you can potentially run it on the same server or just have your cache in the data tier, as long as you can live with the network latency.
Okay. There was a good one I saw just a minute ago. Oh yes, it was speaking on the future. Is there any plan for future versions of it to have, for in-memory to have an in-memory column instead of the entire table having to be in-memory?
Yes.
Well, having a particular column in memory, yeah, that is that
sounds
format.
like you would just index it.
Yeah. Well, our index. I mean, the data structures we chose are very much, you have your rows, your full row is there in memory, and your indexes just point to your rows. So you would,
right.
We in principle we don't duplicate data between
Sure.
in the index and the base table, right? So this kind of scheme is not something we are currently looking at. I mean, we might provide some support for something like that in the future. This actually relates to a request we have heard previously, to provide some form of compression. Right now, I mean, so this is something we are always considering, of course, but it's not, to be frank, not very high on our list, because we want to. What we are focusing on mainly is to keep the performance very high. We don't want to give up on the performance that we have, and we want to mainly expand the potential use cases, expand the surface area that we have, expand the query operator inside Navier compile procedures, those sorts of things.
So Joost, let me add one more thing on that, right? I mean, a specific column may be a extreme, but suppose you want to have subset of columns of a table into in-memory. Of course, you can break the table into two parts, right, and join them through a primary key, and then you could do it. And of course, there are implications with respect to application, but yeah, that could be done even today. But not, you just cannot say this table has 20 columns and you just say column 19 is in memory. You cannot do that, and I think the reason is given by Joost.
All right. All right. So I'm seeing this question continue to pop up. So let's go over it. So the question is essentially non-durable tables are not logged. That means it will not be in the transaction log. Is that correct?
Correct. So there is actually if you look at the default mode for in-memory OLTP table, we say the durability is the option. Say the default option is schema and data, right? So when you think of disk-based tables, which is your traditional SQL tables, we persist, of course, the schema as well as the data. So when you restart SQL Server, table is there and the data is there, right? For non-durable tables, the only thing we persist is the schema, not the data. So it is not logged. So that is actually a benefit, because you want to eliminate the overhead of logging and as well as storage. But since the schema is persisted when you restart the SQL Server, let's say you were using this in the non-durable table in a ETL scenario, you don't have to recreate the table because table already exists, and you just have to load the data again, right? This is different than TempDB, where, I mean, if you were staging into a temp table, the temp table has to be recreated because temp database is completely wiped out, not only with the data as well as with the schema. So the long answer to the basic question, yes, it is not logged.
All right. So next, we've got two more groupings of questions. One's on Bitbucket and one is on how do we determine sizing, whichever one you want to go with first.
Go for it in that order, that's fine.
Okay, so So let's say you've got your bucket limit specified, and now you've exceeded it. Now what?
Yes, so I assume this refers to the bucket count of a hash index.
Yes.
So
That's right.
the bucket count of a hash index determines the size of the hash table. Now, this does not determine how many rows you can have in the index, because you can have several rows in each bucket. That's usually how a hash table works. You can have multiple values end up in the same bucket. It will just, this like called a hash collision. So what we essentially have is in each bucket there's going to be a linked list of rows hanging off that bucket. And usually when you have a hash index with the same number of buckets as the number of rows that you have, let's say there's a one-to-one relationship in size, then because of the nature of the hash key, which is kind of a semi-random, the hash function, sorry, which is a semi-random function, you get a pretty much a random distribution of keys over the buckets, which means in practice, well, technically you get a Poisson distribution. You can look up on Wikipedia what that is. But in practice, if you have this kind of one-to-one relationship, about a third of your buckets is empty, a third of your buckets has one row, and a third of your buckets has two rows. And maybe a handful of buckets have more than two rows. And so our algorithms can deal with this perfectly well with these collisions, and everything is still functional no matter how many collisions you have. You can have 1,000,000 rows in one bucket, and still your insert will work, your update will work. They will just not be very fast, because what happens if you want to find a row in a bucket which has a chain of a lot of rows, is you first go into that bucket and then you need to walk this entire chain. So therefore you want to limit the number of collisions. So therefore we recommend to have at least as many buckets as you have key values. But if you have more key values than buckets, things will still start to work. But when all of a sudden you have maybe 5 times as many rows as you have buckets, then your performance will start to deteriorate.
Right, and just let me add one point to that. I mean, this is a common question people ask. So suppose I miscalculated the growth of my table. I mean, I started off correct, but my data is growing every day. How do I change the bucket count? I mean, currently the only way to do would be to drop the table and of course you BCP out the data or move into a disk-based table, recreate the table and load the data back up again. So of course this will have an impact on the application availability, but that's the only way to do it right now.
And one thing also to mention in this case is if you have a table where you're not sure about how much it's going to grow, you think it might grow but you don't know by how much, maybe a little bit, maybe a lot, then just pick a high bucket count. Pick a bucket count of maybe 10 times the number of rows you currently have, because that usually does not impact performance as much.
Right.
10 times number of rows is usually fine.
Right. Just let me ask you, this is interesting. I mean, if as a customer I don't know what the bucket count should be, should I not start with the BW, like the range-based non-clustered index, because that can grow and shrink as the data grows and shrinks? Yeah.
Yes, indeed. So we have the hash index and the non-clustered index, which is the implementation is a BW tree. So this BW tree index, we recommend this as the basic index to start with, and you use the hash index only if you want to optimize particular scenarios. But usually when you want to get started, you want to get started with the non-clustered index.
Right.
That's right.
All right. So we've got, is it possible to use the buffer pool extension area to extend the pool of memory available for in-memory objects beyond the limits of the physical memory on the server?
Answer is no. It is this buffer pool extension feature is primarily for the pages, and in fact read only pages, right? So in-memory OLTP tables do not use pages. They have a different way of using memory, so it is not compatible. But I think I understand the intent of the question is, can I get? Yeah. So no, it's not.
Yeah. No, it is the buffer pool extension specifically extends the memory available for the buffer pool with disk, right? But but memory optimized tables live outside the buffer pool, so
Right.
there's no relationship.
Correct.
Then again, there may be some synergy in some scenarios. Though they will be limited. Like if you have a mixed workload with both memory optimized tables and disk-based tables, what you will always have is that as your memory optimized tables grow, they put pressure on the buffer pool. Right? So then you could potentially extend the buffer pool just for your workloads on the disk-based tables. But still, they are not useful for your memory optimized tables.
Yeah, but I think that's a great point. I think, yeah, in a mixed workload, you can leverage the buffer pool extension to manage the workload better. Exactly.
Yeah. But again, the scenarios there are kind of limited, so you
That's
need to
right.
be careful.
That's
In general, our recommendation is when you use memory optimized tables in memory OLTP, you really care a lot about performance. That is your main consideration, and you will buy enough memory such that your data fits.
Okay. And maybe even reshape your table so that it fits better in memory.
Yeah.
So that if you're limited on the size.
Right. So on that note, let me make one more point. This is actually a very critical thing. So what we have been seeing, I mean, if you look at 2014, the commodity boxes that are being released with like 4 sockets have a memory of 1 terabyte. So it's like a huge amount of physical memory available, and that is like priced under $15,000. I could be wrong, but somewhere in that ballpark. Now, in-memory OLTP has a memory limit of 256 gigabytes. So the key point we are making is performance is the critical consideration when you're thinking of in-memory OLTP, and these boxes with 1 terabyte are available. So in general, you don't have to, the memory may not be as big an issue because you should be able to have that kind of memory to support in-memory OLTP. Anyway, so that is something to just be aware of.
So got about, oh wait, before we go into that, let me ask, did we ever get that link shared out?
Oh, I did not share the link. I thought in the chat window everything was there, but I'm honestly
okay.
wrong.
It's
Hold on. I think
Yeah, if you can,
that makes
if you
sense.
just open my link thing and then just show the
that's
the
the
page.
link. Yeah, this is the page.
Yep.
Yeah.
Yep.
So
okay. Yeah, if you put
if
that
you
in
can-
chat, then
Oh,
Sure
in
thing.
chat. Oh, right. Let me do that.
all right. And then let's see. How can we just? We've got multiple different questions about how do you decide to size for an in-memory table. So, let's think of it both as how do we size given a table that we've got already. Do we need to buy more RAM, or this is how much RAM we've got. Can we get that entire table inside of there? So, does that make sense?
yeah. It's a very complex question to answer because there is no straightforward answer. So let me try, and I think first you need to play around with the system, obviously in the test environment, to see what the memory usage is, right? So here's the deal, right? That let's say I figure out that this is a table which is disk-based table, and I want to migrate that to in-memory OLTP. So question is, how much memory do I need, right? One thing you need to know is, well, that table that you have, disk-based table, has rows and there are indexes, right? So first you have to figure out which indexes are actually necessary when you move to in-memory OLTP. You may need a different set of indexes possibly, number one. Number two, your disk-based table may have a page compression on, right? I mean, you may have chosen page compression, but as Joost pointed out, there is no compression available for in-memory OLTP tables, so you need to figure out what will be the size of the table if it was uncompressed, right? And so you first have to figure out, okay, existing table, the table is say 100 gigabyte, and I need that much physical memory for that, right? That's one. Second thing that you need to understand is that because we use optimistic locking control, there will be row versions. So that really depends on how many versions you are generating and what is the longest duration of a transaction, because that will determine how much space you need to make sure available in memory for row versions. So that I think is a very critical point. And I had one more thing in my mind. I'm blanking out on that. So the row versions and that, right? So so yeah, that's how you do it. And you need to. And our basic is rule of thumb recommendation is just have 2 times the memory reserved for your in-memory OLTP table. So if I have like 100 gigabyte of size of in-memory tables, I would say I should just keep around 200 gigabyte to be on the safer side. But again, it depends on the workload and so many things. Now, if you still run out of memory, the only option is you move the rows from in-memory OLTP table to a corresponding table in the disk-based table. I think this question came up in the morning. But that, of course, makes your application more complex now because data is in 2 different tables, and you need to access through views. There are inconsistencies with respect to transactions running on disk-based table and in-memory table together. So yeah, so it is a more complex thing. And but I think if you go to our books online page, we have quite a bit of content on describing how to provision the memory, how to estimate the memory when you migrate the workload into memory OLTP tables.
Yeah, if either of you have the link to the books online.
I was let me see if I can find it. Hold on. Why don't you go with the second question? Yeah.
Yeah, exactly.
Sunil, maybe you can just keep up the slide. I will go ahead and I will find the link and I will post it in chat.
Okay, perfect. And then getting a lot of questions here. One of them, let's just go with one that stands out to me is can I create in-memory objects with encryption, like specific columns or stored procedures, etc.? You know, thinking from an encryption point of view, how is that impacted with? Can I leverage memory optimized tables while I'm being safe with my data?
Right. So I want to make 2 points. There are 2 kinds of encryption that you can do. One, you can do a encryption at a database level, right? The TDE, the transparent database or data encryption functionality. So at this time in 2014, when you do TDE, enable TDE on a database with memory optimized tables, the memory optimized tables are not encrypted. Okay. This is the restriction comes because memory optimized table storage is based on file stream, and the file stream data is not encrypted today in SQL Server. So you will have encryption issue from that angle, and this is something we are looking into fixing it, right? So it is not enabled through TDE. Point number 1. Now, point number 2 is if you want to encrypt a column, which is external encryption in the sense you store the data with encrypted value, that should work because, I mean, that encrypted value becomes a binary value. So you can encrypt, for example, social security number, right? I can have a function which says, you know, I'll declare social security as a encrypted value, but then I have to encrypt or decrypt based on the application. So I think those are the 2 things. This is how you encrypt the data in SQL disk-based tables, and unfortunately TDE does not work with memory optimized table, but every other table, right, disk-based tables will be encrypted. So one more point on that one. So suppose I have a database with only non-durable tables and some disk-based tables, and I want to use TDE. Clearly, the non-durable tables are not persisted on the disk, so your data is still encrypted. But yeah, for durable tables within memory OLTP, the TDE will not encrypt that data.
Okay.
2 further points I want to make on encryption. One is that, of course, you can always use BitLocker encryption to just encrypt the disk, right? Then all the files, including also the data files for memory optimized tables, will be encrypted. And then you just let the operating system take care of the encryption instead of the database server, right? And the second point is that database encryption, that will, sorry, not database, but backup encryption. So backup encryption does also work for your memory optimized tables. So if you have, let's say, if you want to make sure that all your data at rest is always encrypted, if you use both BitLocker and you use backup encryption, then also all the data at rest for memory optimized tables is encrypted.
Yeah, that's a great point. So let me add one more point on that, even though it's not related to encryption. So backup compression, remember like the data in-memory OLTP data is not encrypted, but backup compression will compress even the in-memory OLTP files used for persisting. So again, going back to the integrated technology, because everything that works with SQL Server disk-based tables continues to work in most cases with in-memory OLTP tables as well.
For this next one, Joss, I'm actually going to try and assign a question over to you. I don't know if it'll pop up over there.
Okay. Actually, the link I just pasted in chat, this is actually an incorrect link. I'm not pasting a corrected link in chat.
So Aaron, can you speak out about the question? I don't see how
Sure. Sure thing. I can.
Oh, it's,
you see it? Yes.
I see something. Wait a sec. Yes, I see the question. Okay, I will answer them. Yeah. Okay.
Okay. And I figured that might be a little easier since there's so many questions. I can start divvying them up. Bucket, determining bucket size. Let's see. Question about, is it possible to check whether a row has already been updated by a separate session before trying an update? If they're worried about the, lack of locking there. So
I think Jos can answer that. Yeah.
I'm sorry, I was answering this question in chat. Can you repeat?
Oh, sorry, no. Sure. If you're asking whether it's possible to check to see whether a row has already been updated by a separate session before trying to run an update.
No, that is not
Okay.
that is not possible. I'm also not sure why you would want to do that. Basically, what we recommend is the error occurs, right? This is a transaction dooming error, and when you see the error, you just retry. That is
Okay.
a general recommendation.
Let's see. Oops, sorry, trying to manage 4 things at once here. Can you expand a little bit more on the mechanics going on when backup of a database with memory optimized tables is going on? What's happening behind the scenes there?
Right. So I think when you think of backup, right, end of the day, backup program, which is backup command, is just reading the files and backing them up, right? So the in-memory OLTP tables are mapped to their own memory optimized file group, which call it a memory optimized file group, and there is one such file group per database, right? And that file group has a set of files which we call as data files and delta files. So you can think of from a backup command perspective, it is just backing up a bunch of files, right? So those files are getting backed up. Those files could be disk-based table data or in-memory OLTP table, right? So that's one thing. Now also the backup command is in sync with the checkpoint. So when the backup happens, it also knows what is the oldest active transaction, where the transaction log point is, right? So backup is going on, and then and now you want to restore the backup. You restore the backup, and then you apply the logs either to the log backups and whatever. It just works like before. So there is nothing unique about backing up a database with in-memory OLTP database. Everything just works like before.
Okay. All right. So for the in-memory file group, can I have the data file point to SQL Azure?
Jos can answer that, but the answer is no at this time. Yeah.
Oh well, no, sure. Oh no, that's indeed. It's not at this time. No, we don't support file stream file stream containers in Azure at this point. no. What we do support though is you can have a VM in a Windows Azure VM and run SQL Server in that. We have prepackaged SQL Server 2014 images. You can just spin one up in Windows Azure, and you can use memory optimized tables in there, and you will have your disks, your virtual local disks there, and you would store your memory optimized tables there, or memory optimized data.
Okay. All right. I'm going to actually let you guys go with any other points while I'm trying to condense. I think we've actually answered related questions on several of these, so I'm going to try and clear up the chat log if there's any points you guys wanted to make while you're...
Right, so I'm just going through the list of questions. This is something me and Jos have put together. So the first question is, memory optimized tables are stored in memory. Does it mean I lose the contents of the tables if I restart the server? Answer is no for the default, which is both schema and data durable. So you don't lose the data. It is the same durability that you get with the disk-based tables. Of course, if you have a table that is non-durable, when you restart SQL Server, you will get the table schema back. The table exists as you defined it before, but not the data. Second question is upgrade. Jos, you want to talk through this one?
Yes, I can talk to it. It is not going to be automatic. If you upgrade to SQL Server 2014, the performance you will see in your app will be similar to what you had before. There may be some improvements because we do performance improvements along the way, but it's probably not going to make a big difference unless you're using the new cardinality estimator. You could get some big perf gains, but in general, you don't automatically use the new in-memory technologies. So if you want to use in-memory OLTP, there is work you need to do. You need to create new memory optimized tables, new natively compiled stored procedures, and you need to migrate your data. And we do have tools that help you with the migration, but there's always work you need to do.
Okay. Sunil, I've assigned you a couple of questions. I'm not sure if you're able to see them. If you can feel free to answer them out loud or however you want to.
I don't know how, where do I see the question? Sorry, I'm acting dumb here.
On the navigation pane on the right-hand side, but I can just read them out. If there's a box that says questions that hopefully should...
Yeah. Okay, please read them out.
Okay, yep. If a native stored procedures are compiled during creation, does that mean that the execution plan can turn out to be suboptimal if the distribution of the data in the table changes? If
answer is correct.
How do we overcome that?
Yeah, answer is correct, but Jos knows this area extremely well. Jos?
Yes. So we don't support auto update of stats on memory optimized tables. So if as your data changes, if you don't change the stats, the plans don't get updated, so you can have suboptimal query plans. So you will need to do regular maintenance on the stats if your data changes. So you will need to manually update the stats regularly.
And Jos, once you update the stats, you have to recompile the stored procedure.
The stored procedures, yes, they need to be recreated. That is correct. Yes.
Right. Actually, having said that, one of the things that I have seen with some OLTP workloads, the typical queries are not that complex. So they are, of course, they are sensitive to the stats. But I mean, in a lot of cases, if the stats may not be as critical for the optimal query plan, is that a fair statement, Jos?
Yes, absolutely. For OLTP style operations, where most of the operations are kind of point lookups or are in the form of nested loops joins or simple like kind of foreign key relation joins of that type. Let's say you have your sales order header and sales order detail type of joins, or you have your sales order detail and product type of joins. Usually these will will remain to be nested loops joins, even if the data changes a bit. Usually you don't get a lot of variation in query plans for pure OLTP queries. It is more for the reporting style queries that you can have big variation. Also the queries there tend to be bigger, and there it makes a lot of difference what join order you pick, whether you use merge join or hash join or nested loops, etc.
Right.
And again, natively compiled stored procedures are not really suitable for reporting style queries. They are really suitable for OLTP style operations.
Right. But actually,
we're
carry on.
Yeah, we're coming up at the end of the hour, so I'm going to make this one the last question. Just a simple, can I select from an in-memory table using update lock read past hints?
The answer is no. We don't have locks. We don't have locks.
Exactly.
So what an update lock does, it prevents any. I believe it prevents any further reads from this row from concurrent transactions. But no, we don't allow specifically controlling this kind of behavior. And again, we don't have any locking. So
let me add one.
Let me ask the question another way. What if a user is just used to putting with no lock on every single table that they query? Will they get an error back?
The answer is no, because we don't do locking. So the no lock hint is for us a no op.
Okay. So it'll just ignore it then?
That's right. The no lock hint is just ignored.
Right. So I think there's another interesting point. Like the question was update log with read past. Typical implementation that I've seen is for the queues, right? I mean, you have multiple consumers from the queue, and they want to pick up the next element that is not being changed. So any application that depends on blocking functionality will not work easily in memory OLTP tables, because it is not based on locking. That's all I wanted to say. Thank you.
All right, perfect. With that, I think we're going to have to wrap it up. It looks like we're about a minute away from the next session, and we want to allow people time to go ahead and get into the next session and go out and click those links and everything and get logged in. So, Snow, I don't know if there's a closing slide, but if there is, if you want to go ahead and put that up.
There is no closing slide. I mean, but it was really good to have this conversation, and keep sending us those questions. We will respond to those offline.
Yes, and we also, so you can, I don't know if there's a forum to send these questions, but we do have on the MSDN forums, we created a new in-memory technologies forum, and both Sunil and I are monitoring this forum, so you can just post any questions you have around in-memory OLTP as well as in-memory column store. You can post those to the forum. I just pasted the link in chat. I'm not sure if everyone can see it.
I brought it here.
Yeah.
Okay.
Okay. Okay.
Yeah.
All right.
Aaron, thank you so much.
Yep. Thank you, guys.
Thank you.
Bye.
Bye.
Bye.